Welcome back, Sheepdogs. In part 2 of the series in Latent Fingerprints, we're going to talk about detection, which covers powders, ALS lighting, and also chemicals. So with that, let's get started. Okay, so the hardest part is narrowing down where the crime occurred at. Sexual assaults occur at any place, any time, any location, any weather. So it is vitally important that once the victim helps you figure out where they were sexually assaulted at, you must attack that crime scene with such tenacity you are exhausted at the end of the examination. So the victim is going to tell you as much detail as possible. Sometimes it's a lot, but most oftentimes it's not a lot, due to time that has elapsed, intoxication, because that's what the offender wants them to be. They want them to be intoxicated so that way they can offend upon their body easier. Or two, the victim just puts their mind somewhere else because they're just trying to survive the attack against their body. So what you're going to have to do is you're going to have to put yourselves in the shoes of the offender. How did they get there? What did they touch? And if you're thinking that it's delayed reporting and the victim doesn't know very much, I'm just going to half-ass the crime scene, you are part of the problem. So get your butt to the scene and start looking for trace evidence and fingerprints to figure out what happened to the victim. Put the offender inside the crime scene using latent fingerprints. So now your butt is at the crime scene. This is exactly what you should look like. You are double-gloved. You have duct tape on all of your seals. You are especially wearing a mask. And you have a hood on to keep your hairs out of the crime scene. I know what you're thinking, but we're looking for latent fingerprints. Latent fingerprints contains DNA from your suspects. So if you're cross-contaminating, your DNA can actually overwrite, if you cross-contaminate enough, your suspect's DNA. This is what you should look like. If you are not doing this, you are faking it. So fix yourselves. So first and foremost, I'm a big fan of oblique lighting. Oblique lighting is taking a flashlight, shining it at different angles, trying to find fingerprints that way. However, I would be professionally negligent if I did not mention Rubis. There are a couple things wrong that I do not like about Rubis, and we'll talk about that. So the Rubis system, also known as CrimeSight, is a reflected ultraviolet imaging system. It is most effective on smooth, non-porous surfaces such as like flooring, walls, and countertops and tables, and on multicolored surfaces like magazine covers. The Rubis uses short-wave UV light. Remember that, short-wave UV light. This light is reflected or absorbed by most surfaces, but with the residues and fingerprints, the UV light is reflected and scattered. Using a special lens and a UV filter, the system converts the UV wavelength to visible light, revealing the latent fingerprint. Since most materials absorb shortwave UV light, the background appears black and only the print is visible. As you can see here, there is a print on this magazine, but when you use the Rubis system, it enhances it. As well as look at this example. This is a fingerprint on a magazine or a plastic baggie that is treated with, it's not Ankylate, but the Rubis system then enhances it and draws it out to make it more visible for our eyes. So if you're at a crime scene and you're having a terrible time trying to find fingerprints, you probably should use Rubis to help you find fingerprints. But you have to remember, there is a cost because it uses UV light, which is ultraviolet light. So what does that mean? The first research study we're going to look at revolved around Carr and her colleagues. This research was based upon blood samples that were collected by law enforcement and lab personnel at crime scenes, how they're collected, how they're dried, etc. Now, a key note inside this research revolved around the degradation of DNA inside the blood. The same concept goes towards latent fingerprints. The factors affecting DNA degradation included environmental conditions such as extreme temperatures, humidity, UV light, and pH. These factors not only modify the rate, but also increase the aggressiveness of degradation. So the key focus for us in this topic is the UV light. So let's explore this further. So that leads us to Kim and his colleagues. They did a really important research study. They looked at the effect of forensic short-wave length UV on DNA. Inside their research, they used the most commonly used Rubis, and that is the lamp seen here. And that's the 254 nanometer level. In this study, the degree of DNA damage in biological samples was compared depending on the distance and time of processing using the commonly used Rubis systems that are out there. 50% of DNA was damaged by treating 10 seconds at 10 centimeter distance in 3 of the types of Rubis that they used. 10 centimeters is like 3.8 inches away. In addition, the degree of DNA damage was increased as the distance was closer and the treatment time was longer. It showed that short wavelength UV could cause DNA damage when used close to the samples at crime scenes. Therefore, they suggest if you have to use Rubis, use it at a distance at least 1 meter away. So take a look at these. These are long wavelength ultraviolet systems. So the researchers talk about this, and they said that the degree of DNA damage was not significant by using these systems, but they have to be at least at 350 nanometer level. And they also have to be also from a distance. So I'm not telling you not to use Rubis, because that'd be ignorant. There are times that Rubis out-trumps anything else, because if you can't find the fingerprints, you can't get anything anyways. So you must use Rubis, but just remember, if you use Rubis, the potential of damaging the DNA inside that link of fingerprint rises significantly. But maybe that's all you have, and that's okay. Just remember what you're doing and what it does. So moving forward, you have now found a latent fingerprint. You use oblique lighting, you use Rufus, whatever, you found one. What's the first thing you need to do? That's right, macrophotography. We'll cover forensic photography in another episode, but for right now, macrophotography is a very close-up photograph of your latent fingerprint. So before you do anything, take a picture of it. Now what? So the first tool we're going to look at powders. Now, it is really easy to overdevelop using a brush and a powder, especially a fluorescent powder. So go very slow and use as less powder as you can, but keep in mind, your brush is making contact with the surface. And then the more contact with the surface you make, the more points of minutia you could be rubbing away. The powder, if you overuse powder, you can obliterate and clog the points of minutia so it looks like a big glob of mess. So practice, practice, practice before you start using a brush and powder. Practice makes perfect. So as you can see, there is a lot of powders and colors that you can use. Powders adhere to perspiration residues and or deposits of bodily oils left on the surface. Experienced crime scene examiners find that gray and black powders are adequate for most latent fingerprint work. But keep in mind, there are other types of powders available for developing latent fingerprints. A magnetic sensitive powder can be spread over a surface with a magnet in a form of a magna brush. The magna brush does not have any bristles to come in contact with the surface, so there is less chance that the print will be destroyed or damaged. The magnetic sensitive powder comes in black and gray and a bunch of other colors, and is especially useful on such items as finished leather and rough plastics, where the minute texture of the surface tends to hold particles of ordinary powder. Fluorescent powders are also used to develop fingerprints, as I mentioned. These powders fluoresce under alternate light sources. So by photographing the fluorescent powder, It brings out more of a context so you're able to see it on the photograph. So the next tool we're going to dive into is Dehydran. It's one of my favorites on porous surfaces. The development of latent fingerprints with Dehydran depends on its chemical reaction to form a blue and purple color with amino acids presence and trace amounts of the perspiration. Dehydran is commonly sprayed onto the porous surface with an aerosol can, as you see here. Generally, prints begin to appear within an hour or two after Dehydran application. However, weaker prints can be visualized after about 24 to 48 hours. Now, if you're in a hurry, the development can be hastened if the treated specimen is heated with an oven or a hot plate, or I've used an iron, of temperatures about 80 to 100 degrees Celsius. The Dehydran method has developed latent fingerprints on paper as old as 15 years. So I can't tell you how many crime scenes I processed, and I didn't even have access to Dehydran. It could have been extremely beneficial in some of the cases, not all, because it only works really on porous surfaces. But that's the part of the problem. It's because of all the ignorance out there, and we were never allowed to develop as actual technicians. We were just kept in the dark, and then those above us either were extremely mediocre or they didn't know about it either, which is part of the problem. So when I was at the military police schoolhouse, this is what we did. So for 39 very long months, I was the chief over the crime scene and forensics branch at Fort Leonard Wood at the academy. And my staff and I, we were really hungry to push our knowledge straight to the edge because we wanted to know everything there is about actual forensic science. And so oftentimes I would spend my own money because we were not supported whatsoever by higher headquarters on what we were doing at the academy for whatever reason. It doesn't matter now. So I got my hands on Dehydran. And so we took a piece of wood, and Josh Whiting touched the piece of wood with just his body sweat. So you can see on the left-hand side, that is where Josh touched the piece of wood. After 6 hours, we sprayed it in Dehydran, and you can see after 6 hours what it did. It popped. So we took macro photography immediately, and then I also had Josh do record prints. That's on the right-hand side. So using the record prints and the crime scene evidence, then I blew it up. And as you can see points of minutia straight off the bat. And that's just from the naked eye. So it's vitally important for you to understand these development techniques, because sometimes you cannot just send stuff straight to the lab. Because think about it. Hopefully you're going to cyanoaculate, which we'll talk about next. But if you don't do anything and you just put the piece of evidence in a paper bag, what are the odds of that fingerprint rubbing against the side if you're not protecting it very well and transport all the way to the lab? It's highly likely. So why take that chance? We'll talk more about superglue here in a second, but why not develop it with Dehydran? Because you're able to, because A, you've been trained on it, and B, you're proficient at it because you practice it all the time. There's nothing that hurts it. And then you have macro photography, so if something happens during transport, you have that good photograph that you can still upload into AFIS. So use your knowledge and then solve the crime at the crime scene. We're going to move on to my favorite technique, and that is superglue fuming. I've used this hundreds and hundreds of times at all different types of crime scenes, all different types of textures and types of evidence. It is one thing that I recommend that you master because it protects the print so well, especially during transport. It also locks in the DNA for lab analysts to get to. So superglue is approximately 98 to 99% cyanoaculate ester. It's a chemical that interacts and visualizes the latent fingerprint so that we can see it. Cyanoaculate ester fumes can also be created when superglue is placed on absorbent cotton treated with sodium hydroxide. As you can see here, you can use a hot shot, which I'll show you here in a second. It also comes in a wand formation, which we never had. I wish we had it because it looks awesome and I want to use it. And then here's a small example in the upper right-hand corner of just how small the chamber could be. I mean, you can use a plastic bag, and I'll show that during the demonstrations. And the two other pictures are showing you how it develops into a white substance. Cyanoaculate also comes in blue from searching, so now you can turn other types of colors, surfaces using blue cyanoaculate, which helps with the photography. So I'm going to show you the hotshot that I have on hand. This is a useful tool at any crime scenes. You can seal it using a plastic bag, a paper bag. It doesn't have to have very much space. You can build a shelf. So this comes in 3 pieces. So it comes with the activator, comes with the super glue, then it comes with the heater that reacts to the activator. All you have to do is take the activator, you pour it into here, and then you see this opening right there. All you gotta do is take this off, drop that into the activator, and then you put the super glue on top of this shelf right here. You put it right on here, and then with a matter of a couple moments, then it starts to evaporate, and then the super glue then starts to fume, and then you have a test control. I like to put like a latent fingerprint on like a lifter. That way when it starts to turn white, I know my evidence is probably starting to be processed. Again, you don't want to overdevelop, so you have to sit there and watch it, or you have like an intern watch it for you, so that way you can continue on with the crime scene examination. So going back and looking at whether sun Ankylate does affect DNA went on the piece of evidence after you fumed it, and it does not. So just in case the supervisor or a colleague tells you don't do this because it's going to affect DNA, you can have a good scholarly discussion with them, but I'm going to tell you it does not affect it. So just look at the research conducted by Angela and Andrew, and they're both from very prestigious crime labs up in the Northeast. And they did 3 very intensive studies looking at not only sun Ankylate but other chemicals, and their results were that it does not affect the recovery of DNA profile from non-porous surfaces. So they're looking at whether or not sun Ankylate degrades, and it does not. They were able to pull full profiles of DNAs from their pieces of evidence even after processing with superglue. So there's a couple more developers I did not talk about, like iodine, fuming, DFO, physical developer, and I believe that those more are reserved for the lab per se. And I feel like I need to say it. You need to have a good discussion at the crime scene whether or not you should be developing your evidence at the scene. You can do it because you're technically able to and tactically able to, but you need to determine whether or not it is prudent to do it, and if the case deems it necessary. Because the men and women at the lab are professionals. They are kick-ass at what they do. Just certain circumstances, you have to do it at the scene. And so you need to weigh and measure what's best for the investigation and what's best for the victim. Because if you screw up the evidence at the crime scene, then the lab can't do anything with it. So take a hard look on whether you needed to do it at the crime scene. But at the minimum, I really need you to consider superglue fuming, because that really locks everything in place, and then it protects it during transportation to the lab. So we're going to wrap up part 2 of this series revolving around latent fingerprints. We talked extensively about the detection, and then I want to move on to photography and development of these latent fingerprints that we have at the crime scenes. I am still pending my supplies from Searchy. I had to go sign some forms for them to prove that I wasn't going to export or something like that. So I'll have my supplies coming in. And so I want to do some practical exercises to show you real time on what it's like to overdevelop or screw up some prints even when I do it. So I want to show you just how hard it is if you don't replicate and practice and hone your craft. And I'm really excited. I want to talk about the one-step fluorescent sun Ankylate fuming process. It's something I didn't know much about, but as I started developing this specific episode, I got more and more into the development, which caused a huge delay on getting this episode out. But it's something that fumes and dyes at the same time. But we'll talk more about that next episode. Until then, sheepdogs, have a Merry Christmas, and I'll see you in the next episode. Remember, be the voice of the victim, always. Sheepdogs!